Let's take a look at the first example. We do not have power of 10 visible, okay? We have to make it visible. Remember, anytime we don't have power of 10, we're supposed to write 10 to 0. Remember, 10 to 0 is equal 1. 1 times the number is the same number. And according to the rule, we're supposed to have number on the left side of decimal point between 1 and 999. In this case, on the left side of the decimal point, I have 0. Okay, so this is not okay with the rule of engineering notation. So what I'm supposed to do, I have to move my decimal point to the right. And because my exponent over here is 0, I have to move my decimal point 3 times. Let's check what we have right now. On the left side of decimal point, again I have 0. I don't want to have 0, I want to have number from 1 to 999. So what I have to do next, I have to keep going with moving 1, 2, 3, another 3 places. And on the left side of the decimal point, I have right now 459. So this is okay for me because this number is between 1 and 999. So I have 459 times 10. And because I moved my decimal point 6 times and my number got bigger, my exponent has to get smaller. Anytime number is getting bigger, exponent is getting smaller. Okay, so that's why I have to write over here -6. Okay, because my number has to be 6 times smaller than 0. Okay, so number is between 1 and 999, so this one is okay. And I got one of these powers of 10. So this is the solution to my problem. Let's take a look at the second example. Again, the number on the left side of the decimal point is 0. We have to have number between 1 and 999. Okay, and I do not have power of 10, I have to write times 10 to 0. Now, because my exponent is equal 0, I'm going to first move my decimal point 3 times to right because I have to get number on the left side of decimal point between 1 and 999. Now, at this moment, I have again 0, so I have to keep going with moving 1, 2, 3. I move another 3 times. And I look at the left side of my decimal point, again I have zeros. So I have to move another 3 times. 1, 2, 3, and I have 67. So I can accept 67 because 67 is the number between 1 and 999. So I'm going to copy this 67.5 times 10. And you have to count how many times you move the decimal point. 3, 6, 9. Okay, my number got bigger, so exponent has to get smaller. Number got bigger, exponent has to get smaller. Okay, so I'm going to have -9. Why? Because 0 minus 9 gives me -9. This number is between 1 and 999. I get this power of 10, so this is the solution to my problem. Let's take a look at the third example. Again, we have 0 on the left side of the decimal point, and we're supposed to keep moving the decimal point to the right in order to get the number different than 0 on the left side of the decimal point. And we're supposed to keep in mind that exponent of my power of 10 is supposed to be one of these exponents. Okay, we are going to move the decimal point to the right side, means the number is going to get bigger, exponent has to get smaller. Okay, if I'm going to move my decimal point once to right, okay, my exponent is going to go 1 down, so this is going to be -8. If I'm going to move one more time, it's going to be -9. But I still have zeros on the left side. If I'm going to move one more time, I'm going to have -10. If I'm going to move one more time, I'm going to have negative 11, and one more time is going to be negative 12. I have 853 times 10 to negative 12. The number on the left side of the decimal point is between 1 and 999, and I get power of 10, okay, listed in my table. Okay, so I have 10 to negative 12, so I can say that this is the answer to my problem.